Canada, a name that conjures images of vast, untamed wilderness, of towering mountains, ancient forests, and icy Arctic expanses. This immense land, stretching from the Atlantic to the Pacific and north to the pole, holds within its embrace a breathtaking diversity of life. But Canada is more than just a stunning landscape. It is a place of profound discovery. A nation where the spirit of inquiry constantly pushes the boundaries of our knowledge. Here, the Earth itself seems to whisper its ancient secrets, and dedicated scientists listen intently, eager to understand. The sheer scale of this country means that mysteries still abound. Hidden beneath its waves, locked within its rocks, and even coded in the very fabric of life, revelations await. These are not just minor footnotes in the grand book of science. They are often chapters that reshape our understanding of the past, the present, and even the future. From the deepest oceans to the microscopic world of genetics, Canadian ingenuity and perseverance are bringing forth wonders. In recent times, a series of remarkable findings have emerged from this northern land. Each tells a unique story, a story of life's tenacity, of Earth's dramatic history, and of humanity's relentless quest for knowledge. Off the rugged western coast of Canada lies a hidden world, a world of perpetual twilight, immense pressure, and cold, dark waters. This is the deep Pacific Ocean. For centuries, its secrets remained largely unknown, guarded by the vastness and hostility of its environment. But human curiosity, coupled with technological innovation, has begun to peel back the veil. Remotely operated vehicles, our eyes in the deep, now explore these alien landscapes. They send back images of creatures and ecosystems that defy imagination, thriving in conditions once thought too extreme for life. It was during one such expedition that a truly astonishing discovery was made. Scientists were exploring an underwater mountain, a seamount, far below the sunlit surface. They were searching for signs of life, for clues about how ecosystems function in this challenging realm. The team, led by marine biologist Charisse Dupré, was using a submersible equipped with powerful lights and high-definition cameras. They navigated through volcanic rock formations, their anticipation building with every meter descended into the unknown. What they found was not just life, but a congregation of life. The key to this underwater nursery lay in the seamount itself. It was not an ordinary dormant peak. This was a place of geothermal activity, a place where the Earth's inner heat seeped out into the cold, dark ocean. The water surrounding the skate eggs was noticeably warmer than the ambient deep sea temperatures. This subtle warmth, a gift from the planet's molten heart, appeared to be the crucial factor. It was a geothermal oasis, a natural incubator for the developing skate embryos. Charisse Dupré's team meticulously documented the site. They measured temperatures, collected water samples, and filmed the behavior of adult skates that occasionally glided through the area. The footage was breathtaking. It showed these usually solitary creatures congregating, drawn to this specific volcanic haven. The geothermally heated water likely accelerates the development of the eggs. Alberta's ancient titans, a graveyard's tale. From the dark depths of the ocean, our journey now takes us to the sun-baked plains of Alberta. This region, part of Canada's vast interior, is renowned for its rich fossil beds. Here, the rocks whisper tales of a very different time, a time when giant dinosaurs roamed the land. For decades, paleontologists have scoured these badlands, unearthing the remains of these magnificent creatures. Each discovery adds a new piece to the puzzle of prehistoric life. But one site, Pipestone Creek, stands out for its sheer scale and the mysteries it holds. Pipestone Creek is not just a collection of scattered bones. It is a dinosaur graveyard of monumental proportions. Thousands of fossils, primarily belonging to a horned dinosaur called Pachyrhinosaurus, have been found here. These creatures, relatives of the famous Triceratops, were large herbivores. They possessed massive, bony frills and formidable nasal bosses instead of prominent horns. Echoes in stone, life and death in prehistory. The arrangement of the fossils at Pipestone Creek provides compelling evidence of social behavior in Pachyrhinosaurus. The presence of so many individuals of varying ages, all found together, strongly suggests they lived in large herds. This herding behavior would have offered protection against predators, such as the fearsome tyrannosaurs that also roamed these lands. It also implies a complex social dynamic within the group. Perhaps they migrated together, or foraged as a collective, much like many large herbivores do today. The bone bed is a frozen moment, capturing this social aspect of their existence. Theories about the cause of their demise abound. Was it a massive flood, sweeping the herd away? Or perhaps a devastating drought, concentrating them around a dwindling water source before they succumbed? The geological evidence at the site is crucial in deciphering this mystery. Layers of sediment tell a story of ancient rivers and floodplains, a breath of new hope, the fight against cystic fibrosis. Our journey of discovery now shifts from the ancient past to the frontiers of modern medicine. Here, in Canada, as in many parts of the world, scientists are engaged in a relentless battle against diseases that cause immense suffering. One such condition is cystic fibrosis. It is a cruel genetic disorder. It primarily affects the lungs and digestive system. Thick, sticky mucus clogs airways, leading to persistent infections and breathing difficulties. For decades, cystic fibrosis meant a life of constant struggle, with limited treatment options and a shortened lifespan. But the landscape of cystic fibrosis treatment is undergoing a profound transformation. This change is thanks to groundbreaking research into the very genetic roots of the disease. A significant part of this revolution involves new drug therapies, often referred to as CFTR modulators. These drugs are not just treating symptoms. They are designed to correct the function of the faulty protein that causes cystic fibrosis. This is a monumental leap forward. It targets the underlying cause of the illness rather than just managing its consequences. The unfolding tapestry. Canada's enduring quest. The discovery of a deep-sea skate nursery, warmed by volcanic vents. The unearthing of a vast dinosaur graveyard, telling tales of prehistoric herds. The development of life-altering therapies for cystic fibrosis. These are but three threads in the rich and ever-expanding tapestry of Canadian scientific endeavor. Each discovery, distinct in its field, shares a common origin: the insatiable human desire to understand, to explore the unknown, to push the boundaries of what is possible, and to make a difference. These remarkable achievements are not the result of isolated genius. They are born from collaboration, from teams of dedicated individuals, often working across disciplines and borders. Marine biologists, paleontologists, geneticists, doctors, engineers, and countless support staff all play their part. They persevere through challenges, through long hours of meticulous work, through moments of doubt.